already started to post with their information. Please do make sure that you've posted to all panelists and attendees. If you post just to all panelists, then only the CUP staff, Cambridge University Press staff, can see you this morning. So do make sure you change to all panelists and attendees. Thank you so much. I love seeing where people are joining the webinar from. We're covering such a wide geography here. We have Delhi, Punjab. We have Uttar Pradesh. Oh, and places that I'm not sure. Ritma.
Yes.
Yeah, can you
All
see?
across. That's amazing.
I
I love
know.
the ideas
Oh,
of these
Gujarat. I know
webinars.
where Gujarat is. I've been to some of these places, but not all of them.
Wow.
Welcome, everybody. Do make sure you are changing to panelists, all panelists and attendees. I can see some people are posting just to panelists. That means that only us here at CUP can see your messages, and it would be wonderful if everybody who's joining today can see where everybody is from and who everybody is. So do take a look at Simon's screen before you post. It'd be great to know your name, the state in which you are based, your role, and what you are. If there's anything in particular that you're looking forward to finding out about today. In a couple of minutes, I'll do a little introduction to the CUP staff on the call today, on the webinar today. Another reminder to change to all panelists and attendees when you're posting in the chat. It's great to see that we've had a couple of mentions now of what people are looking forward to learning. So teaching mathematics in the Cambridge way, absolutely. Innovative teaching and learning practices, I'm very hopeful that that is what you will see this morning. Okay, I'll just let people do change from all panelists to all the panelists and attendees, so that everybody can see what you're posting. Thank you to those who have already done so. If you originally posted to all panelists rather than all panelists and attendees, you might want to copy and paste your post so that everybody can see that. I'm just going to give one more minute and then I will start with introductions and we'll get going with our webinar this morning. Lovely, thank you so much. Please do make sure you're posting to all panelists and attendees. Have somebody looking to teach strategies for teaching fractions to grade 3. On this webinar, we're probably not going to go into that much detail on specific ways of teaching things to specific grades. This is a 1-hour webinar, so unfortunately we don't have the time to go into the details of teaching every aspect of mathematics to every grade. But we'll certainly look at some active Cambridge approach strategies that you can apply to many grades and to many topics. Okay, I think we're going to start introducing all of our wonderful attendees to our panelists today. So today's webinar, as advertised, is going to be hosted by Simon Lind, who is a senior Cambridge consultant, education consultant, and he's going to talk to you about the texts we have available for primary maths and also how to use them in an active student-centered way. We also have Rudham Maqbal, who's the head of marketing at the Cambridge University Press India. We have Gina Hurry, who is the Cambridge in the Cambridge office, who is our new Continuing Professional Development Operations Executive. That rolls off the tongue. And it's Gina's first week here, and she's here to learn about what we do, about the CPD we offer around the world. And I am Victoria Renfro, and I am the CPD manager here in the Cambridge office. I'm just going to, just before Simon starts, just for a brief couple of minutes, I'm going to hand over to Rudhima, who's going to let you know about some exciting opportunities specifically in offered by Cambridge, India. Over to you, Rudhima.
Hi, thanks, Victoria. Hello, good afternoon, everyone. Welcome to our second webinar in this series. All these webinars in India will be hosted by our Cambridge teacher community, which is called Teachers of Tomorrow. And I'm Rudhima. I'm the community manager for this community. Victoria, can you allow me to share my screen?
Absolutely. One moment. I say that with such confidence, don't I? But it's not been playing nicely with us this morning, has it? But let me just see what we can do here. If I claim host and
I can. Perfect.
Yes, you should be able to share now, Rudhima.
Yes, I can. So what is Teachers of Tomorrow? Teachers of Tomorrow is an online platform for educators to share their experiences with peers in form of articles, videos, worksheets, and white papers. We keep on seeing and hearing a lot of your stories on Twitter, on Facebook. We thought, why not create a platform where you can share these moments with the whole world? I can see Shalini ma'am, who's a very, very active member of our community. She's written brilliant articles for us on active learning and maths magic. So hi, ma'am. So do check out the community where you can share your experiences, you can interact with other teachers and talk to experts like Simon. And also to keep this running and to get it all exciting for teachers, we have a contest coming in next week, which is the Better Learning Moments contest, where we are inviting and rewarding teachers to celebrate your efforts in the classroom. The contest is called Better Learning Moment, which will start next week. All you have to do is fill up a form and share that aha moment which you have created in your classroom using a Cambridge resource, and just upload a picture or a video and how this Cambridge resource has helped you achieve that moment. And all these exciting entries will be rewarded and lots of goodies and prizes to be won. So all the best to all the teachers out there. Feel free to reach out to me to know more about the community or to share your articles and to get featured by Cambridge.
Thank you so much, Rudhima. That sounds very exciting and some good prizes there. Great. Right, and without further ado then, I will hand over to Simon. So I'm just going to change settings slightly so you'll be able to see Simon's screen momentarily. Okay, Simon, you should now be able to share your screen and unmute your microphone. Sorry for the delay here. I think, oh, here we are. Simon, I think your microphone is muted.
Is that better?
That's much better. So we can hear you, but we're just waiting for your screen.
And can you
Perfect. Great. So just before you start, Simon, I'll just give one last reminder then that as you join, please do go to chat. Please do, first thing you must do is change the to from all panelists to all panelists and attendees. So please do change that from all panelists to all panelists and attendees, and then go ahead and introduce yourself with your name, the state in which you're based, your role, and what you are looking forward to learning about today. And it's great. I'm really enjoying seeing these as they roll in and seeing the diversity of locations and experience and expectations. Great. Simon, over to you.
Okay. So has that worked? That has. Brilliant. Good morning, everyone, and very much a warm welcome from me. It's good morning in England. Good afternoon to you. I was going to say good afternoon to you in India. That's better. Sitting here in England at the moment, it's a bit dull, overcast, a bit miserable and grey. And I'm sure wherever you are in India, it is a beautiful, warm, sunny afternoon. I'm very jealous. So without further ado, let's get on with a little bit of the mathematics. Today, what we're doing is we're going to be looking at the Cambridge Mathematics resources and then some ideas of how to make them very much active learning, and some key strategies that I'm going to share with you to improve overall maths teaching and learning. That's the basic idea from that. So very quickly, this is roughly what we're going to do. A few minutes of introduction. I'm going to look at the course structure, some teaching approaches. We'll walk through a lesson, and I hope that at the end of this, it will make a bit more sense to you. I'm also got to be very aware of the time. So without further ado, let's have a look at a simple question there. And I've put up there, how is primary maths teaching different? Well, the key way is that we must move away from this idea where teacher talks most. Classrooms are quiet, students learn by memorizing facts. And when we think about making a mistake, children are terrified to make mistakes because they'll be shouted at, or they'll, their parents will be very cross with them. We focus lessons around students completing written tasks only. We don't listen to them. We don't give them a chance to view their thoughts. And teachers speak just to give information and instruction. So it's very, very one way. In our maths world, we want to celebrate actually a classroom environment where there's a lot of student dialogue, and particularly where the students are talking to each other. Now that's a real challenge, getting that step away, because I've been in so many classrooms where I get students talking to the teacher very comfortably, but not to each other. So we need to think about, can we do tasks where the children talk to each other? They share ideas. I'll talk a little bit about that later. We want our classrooms to have a busy noise. We want students to learn from the teacher, the textbook, but also each other. And that's a key one. There's a lot of learning that can take place from each other. And children need to be able to feel free to make a mistake. You learn from that. It's not something that's negative. A mistake shows that they're trying. They may not be there yet, but we as teachers also need to recognize that children are on a learning path. They're never going to get everything right immediately. Even we don't. So we need to think about how we actually do it. We need to get our lessons focused around the fact that we focus on what our students are learning very much, rather than what are they doing. I'll talk a bit more about that a little later. And when we also think about that, we must recognize that our teachers are constantly in dialogue with everyone. And although it just says students on the slide, we also need to think about teachers talking to parents, teachers talking to the wider school community about what they're doing and sharing ideas. So just for a few minutes, just give a little bit of thought. Are you on, or are you somewhere in between and you're wanting to move that? So just literally a few seconds to think about that. And then, just to round off that one, are there any barriers to using this approach to teach in your school? So what's actually happening in your school? Do you have parents, do you have senior management that actually stop you from doing this? Or are you encouraged to do that? Now, Victoria, my next slide is asking questions. Are you ready for that?
You know what, Simon? Unfortunately, I can't access the taskbar at the moment, so we might have to pop back to this. I'm afraid that I'm having some technical issues with my computer this morning, and I might have to actually leave the webinar and pop back in again. So we might have to just skip over this bit. I'm sorry about that. And if I disappear, I'll be back on again in a moment.
Yeah. That's fine. So in that case, everyone, what we'll do now is we're going to have a quick look at how this is all structured and what it actually means. So on this one, I've got very briefly, it's a 6-stage program for teaching mathematics. Now, in fact, primary is 6 stages, but we get mathematics that goes all the way through. Now, something that is very, very special about about Cambridge Maths is that with Cambridge Maths, we have a very different approach. Now, the reason for this is that the university, and we are a university first and foremost, some years ago was getting quite concerned about the way that students who are coming to the university were not able to think for themselves. They could do maths, they could solve, well, they couldn't solve problems, but they could do and memorized lots of long equations. But when you gave them something new, they couldn't apply that learning to the knowledge they had. So this meant that Cambridge University, and this was a collaboration between Cambridge Assessment, the Faculty of Education, and the Faculty of Mathematics, designed our current maths course. Now, one of the things that we know, that it has a problem-solving approach, focuses on real-life contexts, but it's also very, very much a concept-based course. We want our students to understand the mathematics, not just do the processes. It's endorsed by Cambridge, and it's also very compatible with your local curriculums. So whenever I've been to India and I've had a look at what the expectations are from the CBSE curriculum or from the ICSE curriculum, it fits in with that. There is a slightly different teaching approach, but the curriculum framework and the way that we look at this is compatible with all of them. So if you come from that kind of a background, yes, Cambridge will be challenging initially, but it shouldn't be anything very, very different. So let's have a quick look at the way that the course is designed and structured. Now, what you can see on the slide there are some of the pages from the teacher resource. I know that you have 2 semesters, but it's designed, if you like, 3 terms. It doesn't really matter whether it's 3 terms or 2 semesters. It's a very, very flexible teaching approach. So the first thing to recognize about Cambridge is that just because it's laid out in a particular way doesn't mean to say you have to do it that way. That means that if you want to teach all number together, for example, or if you want to teach all geometry together, you can. Just select the appropriate units and you can put them all together. Just because we've put it out as a bit of number first, then geometry, then measure in one term, and then the next term we also do a bit of number and a bit more geometry and so on. If you don't want to do it that way, you don't have to. You've got 9 units spread over 2 semesters, so you can mix and match as you see fit. So if you wish, as I've said there in big red letters at the bottom of the screen, if you want to teach it on a block approach, you can. If you want to teach it by topic, you can. It's entirely up to you. It's how you do it. So this flexibility allows you to plan your course effectively. Now, there are 3 main components: a teacher resource, a learner's book, and a games book. We also have a word problem CD-ROM, and that is an extra that you can buy to the course. Word problems, often called story sums, is basically a language support. So it's typical of the style of questions that you may get in Checkpoint that asks children to think about language as well. A typical example of that might be that they might easily be able to do what is 12 multiplied by 2, and they can snap the answer out just like that. But if you say, well, you know, I've got every week I collect 12 beads, how many have I got after 2 weeks? It's the same thing, but put in language. Sometimes they find difficulty with that. So the word problems gives them a bit of support on that. The key component for Cambridge is the teacher resource. Basically, you cannot teach Cambridge primary mathematics without the teacher resource. If you are using Cambridge Primary Maths and you are trying to base your planning and your teaching around the learner's book, I'm afraid you're going to find that extremely difficult. You need the teacher resource in order to be successful. Now, the teacher resource is very simply, you cannot teach without it. It has everything you need in there to not only plan your lessons, but deliver them as well. I strongly recommend that for every maths lesson, the teacher resource is open on your desk at the correct page for you to continually reference. If you have the teacher resource and it's sitting on a shelf or it's in the common room somewhere and it's still wrapped up in its paper, you have a problem. It has all the content in it, all the structure, everything that it needs. Also has all the references, the resources, so that everything in there is what you need to plan and deliver your lessons. Now, a key thing about the Cambridge approach is that there is a variety of teaching strategies. So within the book, you will see, for example, if you're teaching children to do multiplication, there are different strategies to approach the teaching and learning of multiplication. So that you don't just teach them one way, you give them an option of learning. So when we talk about, and we had a request earlier for, how do we teach in an innovative way? This is the kind of thing that I think is there, because we're not just teaching the children one way of learning, for example, multiplication. We're giving them a variety of methods and allowing them to choose one that works best for them. If you are one of these teachers that loves this concept of different learning styles, which, by the way, if you are a devotee of Howard Gardner, he doesn't like it to be expressed in that way in education terms, but that's outside of this one. But children do learn in different ways. That means that if you offer them a variety of different ways of learning and understanding maths, they will find one that works best for them. That is one really good way of ensuring that children understand. It's not a one-size-fits-all. And pretty much all the answers are there as well. So it helps you in actually you doing the maths as well. So here's an example of what the teacher's resource page looks like. And in this one, we can see very clearly that in this particular page, we don't call them lessons, we call them core activities, because they are called core activities quite simply because they may last more or less time than an average 35-minute lesson. So you may spend 2 lessons doing a core activity, it may be half a lesson. So we try not to say you must teach this in 30 or 35 minutes. Again, there's this flexibility that's built into it. We always expect you to look at prior learning. So again, a key element in your planning is what can they do? Can they get this? So in this particular case, we're looking at Unit 2A. It's tens and ones to 100. This comes from a Stage 2 book. And we expect children to be able to count up to 100. Can they count forwards and back in tens? Can they use place value cards? Well, if they can't do that, then you might need to think carefully about how you're going to approach this particular lesson. Now, every unit overview has the objectives. Now, these are from the Cambridge Curriculum Framework. If you are teaching the Cambridge Curriculum Framework, then this is where it matches exactly to it. If you're not following the curriculum framework, but still want to use Cambridge resources, which is actually a very, very good idea, it gives you an idea of how the course is structured and laid out. So it's all there for you when we look at that. There is also reference to what's in the learner's book when we do that. Finally, well, it's probably not finally, but there's another one, keywords and vocabulary. So it tells you what are the keywords, what's the key vocabulary in that. So here's a quicker look at learning objectives. So you can actually plan your learning objectives from that, and it's for each chapter. I'm going to flick through this slide very quickly because I'm going to get to the stage where all of the bits and pieces are there. So you can see, and it's a very brightly colored slide there, full of big arrows and so forth. But basically what it's doing is it's giving you everything. In the teacher resource, all the work is done for you, short of actually you sharing it with your students, all the resources you need, all the lesson instructions, the key vocabulary, the types of questions you ask. When you look at this, as we'll see when we do the lesson a little bit later, but you might notice in the red box at the bottom, you'll see some words written in italic script. So it says, where are the numbers without any tens? What about the numbers with 3 tens? It even gives you the questions that you could be asking your students to help them think about what the mathematical concepts are that they need to master. Again, lots of help in vocabulary. The second and sometimes third page, and again, I'm just going to put all the arrows up. So, oops, sorry, I'm just going to go back one. And you can see that at the end of it, there's a summary. So the summary can be used by you to check their learning. So can they do this? Now, a little bit later on in this, I'll show you how we've laid out a lesson. And this is where I will use this section to form some I can statements. So for example, learners have a good understanding of the layout of 100 square and can talk about the patterns they see. So that's the summary. Now I might turn that into an I can statement for my learners to think about. So I can talk about the patterns in a 100 square. I can talk about what the columns look like and the patterns. I can talk about diagonal patterns. I can talk about horizontal patterns. So take that, turn it into an I can statement. Now, I'll move on very quickly. Look out for misconceptions, questions, further activities. So it gives you a huge amount of guidance. Now, learners' books. Contrary to every other maths program probably in the world, but definitely at primary level, learners' books are not designed to be used at the beginning of the lesson. You don't start with a learner's book. In learners' books 1 and 2, we say that while you are teaching the lesson, it's quite useful to have the book open for the children to refer to. There are questions for practice and discussion, but you don't actually start teaching from the learner's book. It is there for support, for guidance, and for consolidation at the end of the lesson. Now, in learner's books, come on, that's better. Learner's books 3 to 6. That has a totally different approach. In learners' books 3 to 6, so this is for grades 3 to 6, you support it with the core activity. They open with an investigate section to stimulate thinking and problem solving. And it is very specifically designed to be used at the end of a lesson. So you will teach the lesson from the teacher resource, and towards the end of the lesson, you then get them to go to the learner's book and have a look at it. So this is a very typical example of this. If you look at this page, that activity, how many different 2-digit and 3-digit numbers can you make with these cards, is actually meaningless until you have done the activity using place value cards. Only once you've done that activity using the place value cards will that page make sense both to you and to your learners. So they're designed to consolidate, and they're not designed to be used from the very beginning. There is a games book. Now, the games book is also a teacher resource. And again, what it does is it reinforces the activities in the teacher resource and the learner's book. It's very specifically designed to replace the vast and very boring worksheets that are so beloved of many, many schools and teachers, where they just have a worksheet full of sum after sum after sum, which are very boring. The more you give that kind of a worksheet, effectively, all you're doing is giving them handwriting practice. They're not thinking, they're not learning mathematically. If you play some games from the games book, they're actually having to apply their knowledge in a social situation. So not only are they learning mathematical skills, they're also learning social skills. So don't overlook the power of the games book. They're grouped by strand. There are plenty of examples of how the games book features some really innovative games. So, for example, here's multiplication bingo, and instructions for the teacher, lots of resources, and lots of fun to do this, so that it becomes fun. They are having fun. They're also learning, but they aren't aware that they're learning. And yes, I can hear people sitting there and they're saying, but what happens if the parents come in and see that we're playing a game? Well, you have to educate your parents, invite them to come and join the game. Then they will see just how mathematically it is vastly improving their mathematics concepts and practice. So let's move on and think about some very clear teaching approaches that are built into and recommended by primary maths.
I'm just going to jump in, Simon, if that's okay,
Absolutely.
just before we start this next section. I'll just let you have a little breather as well. So I've got access. It's wonderful. I have access to the polls now, so I'll launch them in a minute to let you just take a breather before the next section.
Okay.
I also want to say, if you've got any, having listened to Simon take you through the books there, we hope you maybe are using some or all of these, or you're thinking about doing so. If you have any questions specifically about the resources, please do, you can post them in the chat section. Please do make sure it shows to all panelists or attendees. If you'd like to ask a question just to myself or Ridhima or Simon, you can go ahead and use the question and answer function. If it's a question that we can just answer quickly and we'll type it, if it's a question that we think would be great for Simon to address, we'll take the question to Simon a little later. If the question's a bit too precise, a bit too specific for today about teaching a certain thing to a certain grade, I'm afraid it's not something we'll be able to address here today. But anything a bit more general, we'll certainly have time to talk about. So just then, before we move on, thinking about your confidence in active learning and thinking about how your learners find Cambridge Primary Maths, a couple of polls for you to answer to get you thinking. So at the moment now, we have 2 poll questions here for you to answer. So first of all, how confident do you feel about teaching maths in an active way? So 1 being not confident at all and 10 being very confident. You can choose any number in between. Please do go ahead and vote now. And then further down, we have how challenging do your learners find Cambridge Primary Maths? 1, they find it too easy. 5, it's just about right. Or 10, it is rather too difficult for them. So please do go ahead. Great, thank you. People have started voting. That's wonderful. Great. Wow, votes coming in very quickly. Wonderful. I'll start to give an indication about how they are. We'll share these in a minute, but I'll just looks like most people are saying that they find the Cambridge Primary Maths materials just about right, although some people are saying that their learners do find them too challenging. So maybe that's something we can look at in terms of the activities, the active learning activities that will make it more accessible. Lots of our participants today feel very confident in using active learning. That's wonderful. I'm just going to end the polling. So last one's in, please. I'm just going to share end the polling and share it in just a moment. Okay, ending polling, and I'm just going to share the results. Can people see the results? Or do I share the screen? Can you see the results? Great, lovely, wonderful. Okay, so you can see where the majority of answers fall in there. A lot of confidence there, but then some middling confidence. So we are aware that we've got, a range of people on the webinar today. Most people find the resources just about right, and if anything, it's weighed slightly there to them finding the resources a little too challenging. And I really think that resources such as the maths games could really help to build learners' confidence in that. But I know Sam will have more to say about that in a moment. So if you do have any questions then about the resources from what you've just seen, feel free to post them in the chat or in the questions and answer section, and we'll take relevant questions to Simon a little later. Right, Simon, we'll look forward to the next section.
Right, brilliant. Thank you very much indeed. That was fantastic to see those polls, and it does show that we are, I hope, on the right track. It's very interesting to note that I firmly believe that if Cambridge primary maths is used correctly, it is probably the best maths course around. It is quite difficult to use very, very effectively, but if you've mastered it, and I would like to think that many of our attendees this afternoon would agree with me, if it's used properly, it's really, really effective. So let me have a quick look at some brief teaching approaches to it. The first, I'm sure you're very, very aware of, CPA. And CPA is, let's get this working properly, come on, wake it up, is concrete, pictorial, and abstract. Now, this is a very, very key idea, especially at lower primary maths, when we are introducing children to maths, is that if we are to look very seriously at children's intellectual and social development, children go through very much a concrete stage. I mean, I know those of you who have babies or young children, they go crawling around the floor. The first thing they do is if they see something, they pick it up and they put it in their mouth. They need to be able to touch and taste and smell things. It's the concrete stage. I don't know if any of you have ever gone through the idea, but children will very often, in the next stage, they love drawing, and they'll draw on anything. Curtains, furniture, the walls, the floor, anything. It's the pictorial stage. They are visual learners at this stage. They visualize things. They're not really thinking abstractly. Young children in particular, they haven't yet learned all the social skills about sharing. It's all there. It's they want it. It's them. I know I've got grandchildren. It's all about them. It takes a while before they are able to get to the abstract or symbolic stage. And the abstract stage is where a symbol stands for something. It replaces them. Unfortunately, I've been into maths classrooms, even at grades 1 and lower, where teachers are teaching children abstract. They're showing them the symbols straight off before they've even got, or they don't even know about the concrete or the pictorial. There are no resources in the classroom. So we need to think that the way that we approach maths has to be built on a conceptual understanding. So when we talk about a conceptual understanding, it's understanding the mathematical concepts rather than just going through the procedure. Very simply, as you'll see at the headline there in procedural understanding, it's how do you do it? Oh, I can add things together, but why? Or what does it actually mean? So very definitely at the heart of what we want to try and do at Cambridge is to build this conceptual understanding. Now, bizarrely, but very truthfully, if you actually develop your conceptual understanding, their exam results will improve. Now, people say to me very often, oh, no, we need to teach them to pass exams. I counter, if you teach them to try and pass exams and they get a question that you haven't taught them the answer to, they can't answer that question. But if you've taught them to think, when they come across a question they haven't seen before, and you've taught them strategies to solve that problem, then they are equipped to have a go at thinking and solving that question. Chances are they'll get it right. So actually, conceptual understanding will improve their exam success. I want to move very quickly to two key essential basics before we look at the next stage, which is on manipulatives. Two essential basics that have to be a core part of everything you do at grade 1 and below. And the first one is the 10 frame. Now, you might have been familiar with the idea of the 10 frame that is quite literally just that. It is 10 squares. You can either get physical 10 frames, or, as I suggest, that you actually just quite literally draw it, laminate them, and have lots and lots of laminated 10 frames available for the children to use. On an A4 size paper, you need lots of counters as well. So lots of counters make a huge difference to the way that a 10 frame works. It's a manipulative. It's a concrete object that they can do. So for example, in a 10 frame, we talk about this, and I could show them this there, and we can see there's one counter there. That is what 1 looks like. So children can get a visual idea of what does 1 look like. We can add another one. Oh, look, there's 2. So we can say, oh, that's 2. And they can visualize it. They can visualize 3. They can visualize 4. And we can see that if we get to 4, how many groups of 2 can you see? Can you see 2 groups of 2? Now they are able to visualize 4 as either 4 ones or 2 groups of 2. So with this, you can then start introducing the concepts of subtraction and addition. Well, how many blank squares have I got? Well, obviously I've got 6 blank squares. Can you count them? So if you've got 10 and you've got 4 that are filled in, how can we see that? There's 5. Now, the moment we get 5, you can start introducing concepts of, well, half, because half of the squares have got counters on, half haven't. So half 10 is 5, but this is visual. It's not symbolic. It's not writing it down. It's not going through all the symbols. We can put in another one. So let's put in 6. Now we can have a look at that pattern and we can see, oh, well, we've got 2, 1 vertical column, 1 horizontal. We can see patterns within that. There's another pattern. We've got 7 altogether. But from that, it's very clear that 7 is also a group of 4, because we can see 4 and we can see 3. So now we're learning that 7 is made up of a group of 3 and a group of 4. That group of 4 can be made up of 2 groups of 2. So we're learning all sorts of mathematical concepts visually. Get the children to explore this. By moving 1 simple counter, we can take it away from there and we can put it there. That also is 7. But now we've changed the way that we see it, and we've now got suddenly 3 groups of 2. So 6 and 1 is also 7. So children get a brilliant opportunity to explore this. And we don't have to write anything down. They're thinking, they're conceptualizing, they're building up a visual image of what the numbers look like. And of course, once we've done 10, you can put 2 10s together. That's a 20 frame, or a 30 frame, or a 40 frame. So they can really explore numbers very, very much. After a while, we start introducing them to the symbolic representation. So there they can see the 10 frames, and you can see the written 10 in the bottom. We can fill in there, and we can see, all right, we've got 7 So we've got 7 blue ones. Now we can introduce them to the symbol 7. We can see that very clearly. We can add in 3 red ones, and we can say that's add 3 or plus 3. 7 plus 3 equals 10. There is your symbolic representation of a visual way. And keeping children doing both together is a fantastic way of ensuring that they actually understand the mathematics that they're doing. They're not just learning that squiggles on a page, if I write the correct squiggles on a page, teacher will be very pleased with me, which is one way that I've seen it quite literally. That's what children are doing. Squiggles on a page makes my teacher happy. I don't know what it means, but she's happy. In the teacher resource, plenty more ideas about how we use 10 frames. I did include on that slide right at the beginning 100 squares. I haven't got time to look at 100 square now, but basically every class from grade 2 upwards should have access to a whole pile of 100 squares, different types of 100 squares for visual reference. I actually recommend that 100 square is in their exercise book. It's actually stuck on the front cover or on the back cover of their exercise book for continual reference. Okay, let's move on very quickly and think about one more key element of Cambridge Maths, and that is the problem-solving approach. Now, within Cambridge, and I'll show a slide that shows this a little bit later on, problem-solving underpins everything. So we have data handling, we have measure, we have geometry, we have number, and those are the 4 content strands, if you like, and underpinning all of those content strands is problem solving. It's integrated into everything that we do. So it's not treated as a separate strand. When we talk about problem solving, in a very simple way, we are not just interested in an answer. We want to know, how did you get that answer? So therefore we are asking for a solution, which is the answer plus the method. Now the reasoning behind that is quite simply that mathematics is content or skill, or content, which is knowledge, and processes, which is the skills, what you actually do with it. Now mathematical processes is a way of using content or knowledge in new situations. Now, problem solving gives us those, if you like, ways of dealing with new situations. This is what it's all about. How do we apply what we already know into a new situation? That's problem solving. Now, again, as I've said, what it quite simply means is we are not just interested in the answer. We want to know, how did you get that answer? So your working, showing your working is absolutely vital. So we want to say, if we're doing addition, subtraction, multiplication, anything like that, get the children to show their working. How did they do that? But more importantly, get them to talk about it. Ask them questions. How do you know that? Get them to think about what they're doing. So keep it talking. If you can, get the children to ask each other questions. How do you know that? Can you prove it? Can you convince me? That's a lovely one. Can you convince me? You know, can you really make me understand? A really good one, especially for younger children. Can you show me in another way? Can you show me how else we could do it? That's really key to problem solving, because it gives them different strategies and the ability to think for different strategies. I love this one. Can you explain it to your friend using a visual image or a resource? So get them to tell each other how they did it. That can have some surprising results because they challenge each other. Is there a pattern? That's a different way of thinking. And what's the same or what is different? There are a couple of key problem-solving strategies. The first one, you may be familiar with the idea of trial and error. I much prefer thinking about trial and improvement. Error is, that word has a little bit of a negative connotation that, oh, I've tried something, it hasn't worked, so I'll throw it away and I'll start again. If we take trial and improvement, okay, I've tried something, it hasn't worked, I'm not going to throw it away, I'm going to see if I can build on it. I can learn from that mistake. So think about trial and improvement. It's the same as trial and error. Try something, if it doesn't work, try it a slightly different way. Try and improve your thinking processes. And combine that with working systematically. And that means that when we do it, think logically, smoothly, elegantly, work systematically. Those are the two key strategies. There are others: pattern spotting, working backwards, reasoning logically, visualizing, and finding all possibilities. They're all strategies, but the first two are the key strategies. Okay, let's have a last very quick look at manipulatives. Now, manipulatives are concrete things that we have in the classroom. I was doing some work with a colleague in another country fairly recently, and a question was asked of us. Can we use manipulatives? Do they only get used in grades 1, 2, and 3? And we both said, no, they should be used up to grade 10 and even beyond. So that even if you're in 11th and 12th, you should still be using manipulatives. It can help thinking. So again, similar to our CPA that we mentioned before, CPA was concrete, pictorial, and abstract. Enactive, iconic, and symbolic are different ways of saying the same thing. It helps them to think about it. Symbols, pictures, images, language, and things that they can actually touch. Now, right at the beginning, I saw someone, and Victoria said, no, we can't go into specifics, and I absolutely agree, but she asked about fractions in grade 3. Well, a brilliant way of teaching fractions is to use bead strings, and bead strings is quite literally strings with beads on them that you can partition, that they can be shown, and you can ask children, okay, I'm going to divide my string, and the strings will come in, for example, tens. You'll get 10 beads, 10 beads on a string, sorry, tongue twisting there, 10 beads on a string, that's tenths. So how many tenths have I got? You can make bead strings for different types of fractions, show them, divide them. Counters, again, absolutely essential. Digit cards, 10 frames, 100 squares, 10 squares, 1 squares, number lines. These are all key manipulatives that you need. I would add in there dice, very useful. No classroom is complete without dice, because you can do so many different things, including magic, but that's for another lesson altogether. But we can use lots of different things. Make sure you've got the key manipulatives: bead strings, 10 frames, counters, digit cards. Nice and colorful. You can either buy them or preferably make them yourself. They're very easy to make. If you are able to get double-sided counters, in other words, they have different colors on them, that can be a very interesting alternative to straightforward. Just for the last few minutes of today's webinar, I'm just going to take you through a very quick walkthrough of a lesson. So this is just...
Can I just jump in ever so quickly, just to say we are in the last 10 minutes now.
That's right.
So please do, if there are any last questions, I've been answering some questions that have come in through the Q&A. If you see at the bottom of the screen, there's a Q&A bit there. There have been some questions there. I've been answering those. Feel free to put any last questions in the Q&A section or in the chat function, and we'll see what we can get through. So just 10 minutes left, and we do want to have a little bit of time for you to reflect on today's webinar. So this would be a great time for any last questions. Thank you. Over to you, Simon. Just 5 more minutes.
It's just a few more minutes on this, so it's a very quick walkthrough. As I've mentioned earlier, when we think about the course structure, those are number, geometry, measures, and data handling, underpinned by problem solving. So when we think about that, it's planning. You've seen that before. Here is a scheme of work done by a school which shows how they have chosen to lay out their scheme of work by looking at learning objectives, activities, resources, and any comments about that. So the first thing we need to do is we need to put our lesson into context. What are we actually doing? And for that, I like to think about the learning cycle. And for that, right up at the top is planning your lesson. We have learning intentions, success criteria. In other words, what does it look like? What does good look like? A learning intention is what are the children going to learn, as opposed to what are they going to do. Followed by a learning activity, we then give them some feedback and a chance to improve, and that will inform our next stage of planning. So I want us seriously to think about moving from doing to learning. Rather than what are we actually doing in this lesson, to what are we learning in this lesson? So by asking you to think about a learning intention is to say, what are we actually going to learn? And the activity will help us learn that. So a learning intention describes what people should know, understand, and be able to do. It identifies new learning, and it focuses on skills. You'll see this in action in a minute. So when we look at our teacher reference, what we've got are learning activities and the lessons, curriculum objectives. So what I've done is I've taken that and I've put that into a lesson plan, and I've planned for learning intentions where they can sort, name and describe and visualize 2D shapes. I've got learning outcomes. How do we know they have learnt this? And this becomes our success criteria. So how do we know we've learnt? The learning intention is what are we learning? Why are we learning it? And our success criteria is how do we know we have actually learnt that? In other words, how we recognize that we have been successful. So ultimately, our success criteria, when we are planning this, the steps or the ingredients the students need to fulfill the learning intention. So for example, I've given this, and I mentioned this earlier, about I can statements. So how will you share your learning objectives? At the end of the lesson, I can describe 2D shapes. I can use words to describe a shape. For example, a pentagon has 5 sides and 5 angles. So once we have got that idea, then we can start thinking about how we're actually going to do the lesson. How are we going to introduce it? And in this case, you can see that we could show that and we could ask the learners, okay, what's the odd one out? Get them to start thinking about those shapes. This is a wonderful lesson. I don't know if any of you have done this, but we introduce the lesson, display the photocopy for the whole class to see, ask learners to identify triangles, circles, squares. But there is something that I want to really, really emphasize here. And this is the words, tell me. Because so often I hear teachers ask simple, closed questions. How many sides has a triangle got? And the only answer you can give me is 3. It's a one-word answer. But if we look at those questions, who can tell me the name of a shape that has 3 sides? Okay, that's a one-word answer, a triangle. But tell me something that is the same between a square and a rectangle. Tell me something that is the same. You can't give a one-word answer for that. You have to give a sentence. The children have to express their thinking. They have to express their thoughts. Tell me something that is different. Those words, tell me, can make such a difference to the way the children answer questions. Just something to think about. It's what I might call another innovative strategy. And when we look at planning the learning activities, it's all there in the teacher resource for you. So I've taken that as an example. I've put that straight into my learning, into my lesson plan, we're going to look at some different shapes today. What shape is this? Show one of the squares. And in this one, what we're actually doing is cutting corners. We're quite literally taking a square and we're cutting them into different shapes. And the children are going to do that. Finally, and I can see that we need to end the lesson by getting them to think about what they have done, reflect on it, think about what they've done. And there we can see the checkup section gives them a chance. And I've included that in my lesson plan, checking it up. And my final part of that is using the learner's book for homework. As you'll see in that lesson, we actually did stuff. We thought about what we were learning. We were doing things. The learner's book didn't come out during that lesson. It comes out for homework. So that there it is, homework, if you do it, learners investigate how many new shapes can be made with a 2D shape. My final point, think about your marking, think about feedback. When we do it, there's an overemphasis on grading and giving marks. If you give marks for everything, students just look at the mark. They don't think about the learning, the feedback. Again, I know I'm whizzing through this very, very quickly, but it's this idea of give them something to think about, talk about. So for feedback to improve learning, your students need to know where they are in their learning, where they need to go next, and how they're going to get there. So that if you just give them a mark, that doesn't help their learning improvement. Again, just something to think about. So there's my final one, and I'm just going to do this one. So in this case, my final question is, what changes do you hope to see in your students? Sorry, it says in your teachers, particularly if you're a senior teacher. What changes are you hoping to see in your lessons, in your students, and what will you need in order to prepare that? So from my point, there we are. I hope you've enjoyed that. I'll hand back to Victoria now, and she can do some closing remarks. Any questions, any comments, we can then share it from there. So I hope you've enjoyed that. I know it was a very, very quick whiz through, so I apologize about trying to cram a lot into an hour, but that's all that we've had. So thank you very much indeed. Good luck. Enjoy it.
Thank you, Simon. Simon, can you just pop back to your reflection slide?
That.
Lovely. Thank you so much, Simon. Just for the last few minutes here, I'm going to close out just now, but it would be wonderful. By all means, do just take your own personal notes or just have a think about the questions on the board here. But if you'd like to post your responses to these in our chat section, that would be wonderful for us to see. So what changes are you hoping to see in your teaching? Is there anything you've seen today that you think you might be able to implement over the next week in school? That would be wonderful, or over the next term.
Or even what are you going to do tomorrow? Even
It's Friday, isn't it? Yeah.
Monday. What are we going to do on Monday?
What
Monday
changes?
Morning.
And then what changes do you think you might see in your students if you're going to change some? If you're going to introduce some new aspects, what do you think you might see in your students? And then what do you think you might need to do in order to prepare? And it might be revisiting some resources, it might be using them in a slightly different way, it might be working with your school to acquire some new resources, it might be getting the beads. What were some of the ones you said there? The bead strings. Which I'm very intrigued. So I was talking to Simon about these just then, very intrigued by these and how they might be used.
Yes. Your children are just at the right age, aren't they?
They are, yes. I like to practice on them at home. So it would be wonderful to see any of your comments in the chat function. I can see lots of people thanking you right now, Simon. So thank you, Simon. Thank you, Ridhima. I'll leave the screen and the chat function open for a few more minutes. I'll also leave the question section open just until about 5 past, just in case a last question comes in that I can type a response to. But otherwise, I think this is the last you will actually hear from us. So thank you, Ridhima, thank you, Gina, thank you, Simon, and thank you so much to all the wonderful participants that came along today.
And I'll echo that. Thank you very much. Enjoy the rest of your afternoon and weekend. Bye.
Bye-bye now.